Somebody asked to see the machining process, or the process I use to machine these scales for a Demko knife. So here it is from start to finish. Let me know what you think. I've already modeled these scales, went through a number of iterations. I'm not going to show that modeling process, but I'm going to do an insertion method that maybe you haven't seen before, mostly because there's two bodies in here and I wanted to retain the link. You know what? That's a little... So what we can do here is create... we do this, the derive method. Yeah, and it's a little weird. You click derive, then you choose the object you want to machine, in this case the left scale here, and then we do existing design, click OK, and then you have to choose the file you want to go into. So we'll go into the demo here. Now this is just my standard 4th axis template. There's no toolpaths or anything in here, but it does have my vise and everything set up on the machine and everything, but you see there's no toolpaths. So I'll go back over here and we want to hide my op1 fixture because we just want to get this part located in the stock. So I'm going to just hit J for joint and click on that face and this face, 90 degrees. Good enough. We're going to use a window machining technique. I will flip it, and then I'm going to go here and just drop this down into the stock, and I want it pretty close to the top of the stock there. I'm going to adjust this to like 150 thou. 75, and that's for clearance with the ball mill. You'll see that and why that matters in a minute. Okay. So we've got this set up in the stock. I'm actually going to go into this joint and just drag this forward, put the fixture back in, so I'm dragging it away from the fixture. There we go. That looks okay. Yeah, I can make this out of 5-inch stock, so that'll work. The rest of this makes sense, though. It's coming out of a 3-inch wide bar, so this is 3 inches. I might as well give myself as much clearance as I can, and the thickness is 3/8 of an inch. So we'll save that, and with that, I've got enough to send this up to Toolpath. So we're going to send this up. I am going to choose, whoops, before I do that, I'll show you the trick. Now this is all R&D stuff, so the workflow is a little wonky for doing 3+1 and 3+2, a little different than you might be used to, but I'm going to show you how I have it set up. So we see Z up here, and then Z up here. That is how you will actually run it, but right now you need to tell Toolpath you're doing it the other way. So we'll leave this one, we'll flip the Z-axis. So you need to tell Toolpath as if you're machining it like with a 3-axis system. And even though this is called setup 2, I'm going to do that as setup 1, so I will, yeah, that's fine. I'm just going to leave it with setup 2 in there because it matches with op 2, but that's fine. So again, if we go here, we see Z up. Let me turn the model on, model visibility. I don't know why that's all off. So there's the left scale. So Z up is the contoured version, contoured side of the scale, and then Z up is the flat side of the scale for setup 2. Okay. So with that sorted, now we've told Toolpath the 2 directions I want it to look at it from. I can send that to Toolpath, and even though it's 2 in 1, it will respect the ordering here, so that's fine. It doesn't care about the name. Oops, I forgot to select the model. Okay, so we got to go in here and oh, I know what the problem is. when you do a link like this, it doesn't put it into the part file. So, okay, I don't know how this derive thing works. So I'm just going to break the link and put it in the part place. And that will now, because of the container method I'm using, that will now work. Okay, so we send this up to Toolpath. Maybe? If Fusion doesn't lock up on me here. Okay, it was just thinking. All right, we'll save that just in case Fusion decides to be difficult. And we've got Toolpath running in the background here, doing its thing. But while it does, Toolpath doesn't know that we're going to window machine this, so I will show you the tricks I'm using to tell it how to do that. So I've got this support geometry here. I'll get rid of the stock. And there's some cool stuff you can do on this support geometry. If you didn't know about this trick, any unconstrained sketches can be modified. I'm actually going to, without going into the sketch, so my standard template kind of windows out the whole part like this, and we could do that, but there's a better way if you want to use like a hot glue workflow. Looks like maybe I have the part a little too close to the edge, so we'll draw that back just a little bit. Okay, so that would work as my support geometry, but I'm actually going to suppress that feature, and instead I'll go into the support geometry here. I will draw a new sketch. We'll hide this one, and we'll actually hide the bodies here and project this geometry. Then we'll do an offset, and we're going to do this, I don't know, I'm going to use 1/8 of an inch end mill, but we'll do like 0.18, give it a little bit of extra room there. We'll do like 0.14, that should be fine. Doesn't actually matter, I'm not going to machine all of that out, but you'll see where I want a little extra room for the clearance on my ball mill. We'll bring this body back, we will finish the sketch and extrude this down to here. Make sure it's only cutting, yeah, we don't want it cutting the workpiece, so only cutting that. Now we can reactivate up here. All right. So we've got our part in a window, and this sort of narrow gap is nice because of the way I'm going to cut the part out. It puts the hot glue, I'm going to use a hot glue method, and it puts the hot glue in shear instead of in bending to have a thin wall like this. So that's pretty good. So I'm going to save that. I've got all my support geometry and everything set up. And I already have my tool library set up in Toolpath, so I didn't have to do that, and we'll do that in another video here. For some reason, Toolpath doesn't think it has a tool to match this profile. We can see there was some kind of an error on the profile, so that's something I will have to make sure to actually add in is a profiling pass. But we can see that it respected the setups. Setup 1, setup 2. Setup 1 is from this direction, the contoured side first, and then setup 2. And if we wanted to, we could go look through the strategy that Toolpath thinks. Now I have some preview features on, so we're showing the toolpaths and stuff. I can also have it show like the IPG as it works. Obviously, the machine strategy is going to be a little bit different there. Yeah, okay. But I'm just going to grab Export to Fusion here and pull this down into the current document. It'll automatically change me over to the manufacturing workspace. And we can go take a look at what we got. Okay, so we got lots of errors. Oh, okay. This is because I reordered the stocks. So I need to do from solid on this one and select stock. And then on this one, and this is just because of the direction I put the part into the workpiece on. I could have done it a different way. I probably should have flipped the joint and worked a little differently there, but you know, the way you import stuff does matter. Okay. So now we can do that and see what we get. Okay. So Toolpath didn't know about, about my window machining. I don't know why it's aligning the part weird when it opens up the view like that. Oh, because I was in the wrong setup view. There we go. All right, so Toolpath didn't know about my support geometry. In fact, it still doesn't. So we can see that it's trying to rough everything out. Because I have the fixture in there, it's not hitting the vise, but that's not exactly what we want. So I'm going to go over here and go here. I'm going to choose my support geometry and add that in. Now, this will have a couple of interesting effects, but the first one is that it'll only rough out, the majority of my my part, and it'll ignore the support geometry. So that's fine. The other thing it'll adjust, though, is that heights that are referencing the bottom will now use the bottom of that support geometry. So I will show you for other toolpaths one other technique that we could use. So like for this adaptive, we can do the same thing there. We can do the model because it won't go down past there. So we can do model and support geometry and hit OK. And this is coming in here, coming in here. Okay, that's a wall profile there. Even though it said it couldn't do the profile, it converted it into a wall and did it anyway. I'm going to go add multiple finishing passes. Now, you just notice like Toolpath chose like wall finish. There we go. It's choosing all these presets for me, so I'm not really paying close attention to my feeds and speeds because I know I have these all dialed in. Okay, we can see that it breaks through the wall a little bit there, but that's okay. I'll take that. Oh, the other thing is that wasn't roughed. So I'm going to go into here, and I'm going to change it to a ramp. And I don't know, 4 degrees ramp and 0.125, something like that. 0.0 10 thou clearance height, and that'll do a better job ramping in there. And that'll give me a nice smooth behavior. Now here for the first time I do need to be a little bit careful. So instead of setting the model, instead I'm going to add avoid surfaces. And you cannot choose, oh you can, okay. Cool, so those are all avoid surfaces and we'll hit OK. And that should generate pretty quickly. We'll see. Surfacing looks okay, but while it's thinking about that toolpath, I'm going to go in. Toolpath created this geometry. We're not going to worry about that for right now. I'm going to create a new component. I'm just going to call it surfacing support. And inside that component, I'm just going to go in here and quickly patch over this hole, this one, this one. Here we go. Because I don't really want that scallop toolpath dipping into those holes or trying to like walk around them to avoid them. So, all right, we're going to go into the scallop toolpath. So you saw quickly, let me just go over that. See how it's like skipping all those holes and everything, and the pattern kind of migrates around those. I don't want that. I want it to machine as if those holes were not there. So we'll go into the model here and we will choose this, and I'm going to pick up that surfacing support guy, and that should be sufficient. Okay, so if I turn on the support geometry, This is why I was a little careful to... Oh, it didn't... Oh, I know what the problem is. Okay. It didn't fix it there, and that's because Toolpath had already pre-selected some bounding geometry, and we don't want that. So, got a couple... Whoops. We got a couple of options. We can either delete all Toolpath selections and then reselect them, or we can just delete those holes in the middle. Like that. And now we should get the toolpath we want. Yeah, there we go. So now it's this. And so this issue is why I had it, I have a tapered ball mill. Something is cutting into the edge of this, so I'll have to look into that and see what's doing that. I don't actually care that much. Oh, okay. Here we go. So this guy... Toolpath, this is an issue because Toolpath is using a pretty big tool for this. We're going to edit this and select a different tool. Okay, I have some duplicate tools in here. That annoys me. I don't like that. Must have had some tools sitting around in the original workflow template. I'll have to go clean that up, but it's really easy to fix. If we go into here and just look at this, I'm just going to delete any tool that's not currently being used. That way there's no duplication. Now I only have tools that are used, so that's fine. And then for this one, I'm going to switch it to an 1/8 inch end mill. So I'll go into my library, my SIL core tools, I'll choose my 1/8 inch end mill. And we will use the slotting toolpath for that, slotting preset. Hit OK, and that should give me better results. Okay, so now I need to regenerate this stuff. Yes. While it's doing that, I will check a few other things. We can hide this support geometry now. Those look okay to me. It's going into some little counterbores there, so I'm fine with that. Flat wall, toolpath. Could do a better job combining these toolpaths together, but that's fine for now. It comes in here and it machines that out. That's fine. Does that bore hole, then it does a bore in there, and then it goes in and machines the walls there, and then bores those out and those out. Yeah, so I'm okay with that. That is op 1 done. Now, there's nothing 3+1 about op 1 here, other than I had to make some changes to get it to ignore my support geometry. But I'm pretty good with that. We're going to let that finish up. Now for the tricks for how to get this to work. Now, the truth is I'm not going to use much of this. The backside is so simple, and I don't want to use a facing toolpath, so I'm going to end up discarding most of it, but the basic approach will still work. So while we wait for this stuff to finish calculating, we'll start on op 2. Okay, so basically, I don't want to use any of these things, but before I do any major changes, obviously, if we're using 3+1, I'm going to flip the z-axis back to be the same, basically the same orientation as, as setup 1 there, or what I'm calling setup 2. So now they have the same orientation. That's how Fusion wants it to be. And then I would go in and use tool orientation to flip the z-axis here. Come on, Fusion. There we go. Tool orientation, flip z-axis, and for this one toolpath, whatever it's boring out there, which I think is, yeah, there's a bearing pocket on the back of the scale, and that's what it's boring out. So we're happy with that. We're going to delete these guys, though, because I don't want to use them. And instead, we're going to use a 3D adaptive with my, I like my 1/4 inch, and we'll use my adaptive roughing toolpath. We will add the model in here. You know what? I'm not going to do that. That's fine. I'll use the touch and avoid stuff. couple of options, but we're going to use touch and avoid there. We're going to choose support geometry. 0 clearance should be fine. Now we just need to set some heights. I don't want it going to the model bottom, so we'll just do the selection. And no, Toolpath didn't do this for me. It would have been nice if it could, but we're just not there yet for 3+2. It doesn't know about the support geometry or anything like that. So that's on my to-do list to work on. So we'll go up here and generate this. Wow, this is taking an awful long time. I think I know what the problem is. We are going to give this some bounding geometry. Go up here. Bounding geometry. I don't need it going and roughing out any of this stuff or dealing with this support system, so we're just going to give that a shot and see if that'll work. And I've had Fusion do this a few times to me lately. Alright, now it's thinking. Let's hope Fusion doesn't crash on me here. Okay. We're going to save it just in case anything goes wrong. And yeah. Okay, let's give Fusion a chance here to catch up. I guess it's generating some adaptive. We'll have it regenerate this guy. Alright, hopefully that'll move along now. We've got this guy programmed. There's an adaptive toolpath that it's thinking about there. That's nice. It's doing the wrong side of the part because I forgot to do tool orientation. So we'll do that. And this is the kind of stuff that you really want Toolpath to do for you and what we'll be working on soon. Okay, I'm happy with that. It's a pretty light step over. I want the cutting forces to be light because it's essentially only being, especially as it gets toward the end, really only being held in by super glue at that point. So you don't want a lot of cutting forces. And that's roughed out, and then believe it or not, I'm going to do a derived operation, and I'm going to use flat. And here's some nice tricks if you haven't used flat before. We're going to just turn the entire model into an avoid, and then just put that one surface as a touch surface. That seems to do a really nice job bounding that. And we can still use the 1/4" end mill, so that's fine. We'll hit OK. Now, whoop, I forgot to set tool orientation, so we got to go back in and do that again. Oh no, it was there because I drived it, so we're good. And that should be the whole part programmed. Looks like it took me about 20 minutes, but that was talking through everything and included getting the part positioned in the stock. So I think that's okay, especially since I'm not the most expert in 3+1 stuff, so the tool orientation is something I have to think about. But you know, knowing some of these tricks for how to bound it, and honestly still having Fusion like working on a toolpath, means that I feel like we're doing okay here. Wonder why that's a pretty small end mill. T6. I think that's my 16th inch end mill. No. What is that? That's my 1/8 inch. Oh, it's just the ball mill. So it's doing some roughing with the ball mill. We'll change that out. We'll edit that out and get it. I've had Fusion get stuck a few times recently. I don't need it to rough with that ball mill, so we'll have it rough here. And I don't want it going and trying to rough out that channel. So we should check machining boundary selection. I only really want it roughing out this guy. So we'll do tool center on boundary. And that should give me the behavior I want. Hopefully speed it up a little bit. Yeah, I think that's the cause of that slowdown, is it was trying to go in and like rough out the window with that ball mill. Set, these guys to regenerate, which is the hazard of using 3D toolpaths, that anything before that requires regeneration. Okay, well, I'm not going to make you guys sit here. The next thing that you would do, oh, there we go, it finished up. The next thing that you do is simulate with machine, make sure you don't have any collisions or anything like that, and then post out and you're good to go.